Okay, so today I want to start talking a little bit about inverses, or talking about inverses of functions and things like that. Graphically, it's actually pretty straightforward to see. What I have already done on this wonderful little wonderful little video for you is I've went ahead and done part A. Okay, I've graphed the function f of x equals 1/2 x plus 2. If you haven't printed out the notes and done this yet, you might want to do that. So that you can follow along as well. Just pause the video or whatever. Now, let's pick 3 points that are on the graph. So I'm going to pick 3 points. I'm going to pick 0, 2. I'm going to pick the point 2, 3. And I'm going to pick the point negative 4, 0. Okay? Those are the 3 that I'm choosing to pick. Okay? So, this is the function f of x. Again, reminder, f of x equals 1/2 x plus 2. For part P, I picked 3 points. I picked 0, 2. I picked 2, 3. And I picked negative 4, 0. Now, in order to graph the inverse of the function, all we need to do, just like it says on in your note page, is reverse or switch the values of x and y. So 2, 0, if I switch x and y, 0, 2 becomes 2, 0. 2, 3 becomes 3, 2. Okay? And negative 4, 0, well, that becomes 0, negative 4. Now let's go ahead and plot those points. Okay? Okay, so first off, the point 2, 0. 1, 2, 0. There's 2, 0. The point 3, 2. 1, 2, 3. 1, 2. And the point 0, negative 4. Okay. And I'm going to go ahead and draw that line in red. And as you can see, this is f inverse of x graphically. Okay. Now, what do you notice about this? Well, hopefully what I'm really hoping that you notice is that this is just simply a reflection over a certain thing. Okay? It is simply a reflection over the y equals x axis. Okay? Y equals x. If you remember from geometry, your reflections, you go straight to this line, then you go straight to that line. Okay? Eventually, these two lines will cross. But graphically, drawing an inverse function should be really, really easy. Just pick the points and switch the x's and y's. Okay? Now, in order for a function to have an inverse, there's a couple things that must happen. Okay? First off, it must be 1 to 1. Okay? So, in order for it to be 1 to 1, not only does it have to pass the horizontal line test, but it also must pass the vertical line test. Okay? So, the first thing it has to do is pass the vertical line test and the horizontal line test. And the horizontal line test is exactly what it sounds like. If you're passing a line through a function that passes the vertical line test, but then that line does a horizontal line pass that goes through it. If it passes through more than one point, it is not a function. I'll give you an example of that in a minute. Okay. Now, in this case, also 1 to 1 means that each element in the range paired with only one element of the domain. So this is even more restrictive than what a function is. Okay? In this case, each boy has one girl, each girl has one boy. Each x has one y, each y has one x, and that's it. So some of the things that are functions are not one-to-one. Okay? A good way of remembering it again, x and y used only once. Okay? Those are all three ways to see if a function is one-to-one. Okay? For example, you tell me, well, you don't have to tell me, but is this function one-to-one? Well, first off, I notice that it does not pass the horizontal line test, does it? Okay? So it is not one-to-one. Okay? So if it's not one-to-one, no inverse unless we restrict the domain. For example, if we said my domain is everything from the vertex to the right. If we said all x is greater than my vertex, then this would be a one-to-one function. But again, we have restricted our domain. Okay, so hopefully that makes sense to you. All right. Now, here is an example of a function that is one-to-one that students sometimes don't realize. So I'll do this little graph. Hopefully you recognize this as the square root function. Okay? Is this a one-to-one function? Yes, it passes both the horizontal and vertical line tests, so this is one-to-one. Okay? Next, here's another example. You should be able to tell me what parent function this is. I'm not going to tell you. Okay. Does it pass horizontal and vertical line tests? It absolutely does. So is this one one-to-one? Yes, this is also one-to-one. Okay. Now, how do I write inverse notation? It is written right there on your form for you. The inverse of f of x is written as f to the negative 1 of x. Okay. So if I say inverse, you should start thinking, oh, f to the negative 1 of x. Okay. All right. If they are inverses, okay, if I do some compositions, if I do f of g of x, okay, if the two functions are actual inverses, I will always end up with x as my answer. If I do g of f of x, I will once again end up with x as my answer. If those two functions are truly inverses, this will be true. If they're not truly inverses, this won't be true. Okay, so let's do a little bit of algebra. Okay, we've done it graphically. We've talked about how to tell graphically if functions are inverses. Now we need to do it algebraically. Okay, so we have f of x is equal to 1 minus x cubed. G of x is supposedly the cube root of 1 minus x. And I'm asking you, what do I do to algebraically find out if this is if these are inverses? Well, compose them. First find f of g of x. Okay? So g of x is this cube root of 1 minus x. So now I want to find f of the cube root of 1 minus x. So basically everywhere I see an x up in my f of x function, like right here, I'm going to replace it with the cube root of 1 minus x. So f of g of x is going to equal 1 minus this cube root of 1 minus x cubed. Okay? Well, I need to simplify this because, what am I looking for? I want this to simplify down to x. If it simplifies to x, we're good. If it doesn't simplify to x, we're not good. Okay, so I've got 1 minus, well, the cube root of something cubed, that basically cancels it out, right? So this 3 and this 3 cancel out, so I now have, and the cube root cancels out, so I have 1 minus the quantity 1 minus x. Okay, well, what's 1 minus 1? That's nothing. What's the opposite of negative x? That's x. So I get x. So did I get what I wanted when I took f of g of x? Yes, I did. Okay. Now, in order to make sure that you prove it, it has to work both ways. Okay. So we still need to find g of f of x. So this time, I'm going to take 1 minus x cubed and plug it in everywhere where I see my x in the other one. So I have g of 1 minus x cubed. Okay. So now what do I do? So I'm going to have the cube root of 1 minus the quantity 1 minus x cubed. Now, be careful. Don't make that mistake. Okay. There we go. Okay. So as we continue simplifying it, we have the cube root of what happens to 1 minus 1, that disappears. I have negative x cubed, so that becomes positive x cubed. Well, what is the cube root of x cubed? It's just simply x. So did we get x for both of them? Yes, we did. So algebraically, we have proven that these two functions, 1 minus x cubed and the cube root of 1 minus x, are indeed inverses of each other. Okay? So, let's talk about our steps. Okay? The first step, you want to verify that the function is 1 to 1. Okay? Secondly, we want to replace f of x with a y. Then we want to switch x and y. Then we want to solve for new y. And then, last but not least, we want to replace our new y with f inverse of x. Okay? All right. So there are our 5 steps. Okay. We're going to use it on number 2. We're going to find the inverse of f of x equal to 2x plus 5 over 3. Okay, first off, we need to verify that it is 1 to 1. What's the domain of this function? Well, it's negative infinity to positive infinity, right? And what's the range? Again, it's negative infinity to positive infinity. If you have a domain and a range that are truly infinity to infinity, negative infinity to positive infinity, you're golden. It's negative. It is definitely 1 to 1. Okay. So second step, replace f of x with y. So instead of f of x equals 2x plus 5, we're going to now have y equals 2x plus 5 over 3. Next, we need to switch our x and y. Okay, so now I have x equals 2y plus 5 over 3. Now I need to solve for my new y, so I need to get y by itself, in other words. So the first thing I'm going to do is multiply both sides by 3. So 3x equals 2y plus 5. I'm going to subtract my 5, so I get 3x minus 5 equals 2y. And then I'm going to divide by 2, right? So I get 3x minus 5 over 2 equals y. And what's my last step? I'm going to replace y with f inverse of x. And I'm actually going to flip it around too. So the inverse, f inverse of x, is just simply 3x minus 5 divided by 2. Take a look at this function. It should also be 1 to 1. Domain's definitely positive infinity and negative infinity, and so is the range. So we're golden. Okay? So let's take a look at number 3. Okay? We have to find the inverse of f of x equals the square root of x minus 5. Okay. What's my domain of f of x? Well, that's going to be 5 to infinity. Correct? Why can't it be below 5? Because then we're going to have a negative radical, right? Okay. And then what's my range of f of x? Okay. Well, my range of f of x is going to be anywhere from 0 to infinity. Okay. Keeping that in mind, that means that everything's in the front, or in the first quadrant, so I am good. Okay, this is definitely a 1 to 1 function. Okay, so how do we find the inverse? Well, y now equals the square root of x minus 5. We're going to switch them. X equals the square root of y minus 5. Now, how do I solve for y? I have to square it, so x squared equals y minus 5. So x squared plus 5 equals y, or the inverse of x equals x squared plus 5. Okay. Now, you have to tell me that x is greater than or equal to 0. And let me show you what's happening here. We found the inverse. We know it's x squared plus 5. Okay. What's the domain of our inverse? Well, it's pretty simple. You take the range and you flip it, and that becomes the domain of your inverse. Okay. So the range of your original function is the domain of your inverse. So this becomes 0 to infinity. Okay. So likewise, the domain of your original function actually becomes the range of your inverse. So this is now 5 to infinity. Now let's take a look at this visually for a second. Okay, starting out, this is our normal function. This is f of x. Okay, remember it is a reflection over y equals x that we actually have. So this point 0, 5 becomes 0, 5 up here. Okay, so basically, I'm going to draw this in a different color so you can see it. Basically, my function ends up doing something like this. Okay, so why do I have to say that x is greater than or equal to 0? Because if I take a look at my function, my inverse, the farthest back it can go is 0, correct? Okay, and x can go all the way to infinity from there, but it cannot be in the negative, and that kind of makes sense because my range couldn't be below 0 on my original function. Okay, I know that might be a little bit confusing, but make sure that you add this limitation for your function. Okay, that's why it's important to understand what the domain and range is of each function that we're doing. All right. Let's do the inverse. So we've got f of x is equal to x squared minus 2. And I'm telling you that I want x to be less than or equal to 0. So what's my domain? Well, that's pretty straightforward. It's got to be negative infinity to 0. Now, why do you think I have to limit my domain? Look at what I have here. I have x squared. What does that normally look like? Normally that looks like a parabola. It looks like this, right? But if I eliminate everything to the right-hand side, if I eliminate all of this, do I now have a one-to-one function? Yes, I do. Okay, so that again, we need to make sure that we're understanding what our functions are. What's the range of this function? Well, here's my sketch. What's my range going to be? Keeping in mind that I subtracted 2, so I moved it down 2, didn't I? So my range is going to be negative 2 to infinity. Okay. Let's see if you guys can come up with the inverse, domain of the inverse. Okay, so the domain of f inverse of x would be what? Well, remember, it's just simply taking the range of the first one, so it's negative 2 to infinity. And the range of f inverse of x is simply what? Be careful here. Okay. It's going to be 0 to infinity. And I will show you why. Okay. So let's go ahead and find our inverse. First off, we have y equals x squared minus 2. Now I have x equals y squared minus 2. So I have x plus 2 equals y squared. Okay. So y equals plus or minus the square root of x plus 2. Remember, you have to do one or the other. Okay. So, what's going to happen here? Well, I'm going to take a look at my little function here. Okay. I have x squared minus 2. So, and I want to keep it at less than 0. So basically my function looks like this. Okay. Remember, I am going over the y equals x line. Okay. So, if I put in negative 2, what do I get? I get 0, so I would have a point at negative 2, 0. Then what would I have? Okay, I would have, if I'm going positive, then I would have a point what? At, if I go, let's do 0. 0 plus 2, or let's do 1. No, sorry. Sorry. Let's go ahead and do 2. 2 plus 2 is 4 squared, that is 2. So I've got a point at 2, 2. Okay. So it's going to go either this way, or if I chose the negative, it would go this way. Okay. Most people are going to choose the positive, which is why I said my range is from 0 to infinity, because I go 0 and it's going to go on forever. I could have said 0 to negative infinity, but then I would have chosen the negative square root. Okay. But again, I have to be careful. Okay. Okay, for number 5 on your notes, it says use the following graph of f to fill in the missing values. Well, when you have you have the graph there, what is f of 0? What is your x value is 0, so what's your y value? So for part A, hopefully you can put in 3. Okay. For part B, okay, the f inverse of 0, okay, if I'm asking for the f inverse, I now am giving you a y value. So my y value is 0. What is my x value? Okay, so if I look at my chart, my x value is going to be 5. Okay. For part C, f of 1, okay, I'm not asking for the inverse, I'm asking for the of f of 1, so that is an x value. So if I go to 1, if my x value is 1, what is my y value? Okay, it looks to me like it should be about 2.3. And then D, this time I'm giving you a y value of 1. So if my y value is 1, what is my x value? It's got to be 3. Okay, so be very, very careful if we're doing this. If you're looking for f of something, then you're finding f of x. If you're looking for the inverse, that means that you actually have a y value there. Okay, so this is a y value if it's in the inverse, it's an x value if it's not. Okay, let's look at number 6. Let P equal f of t be the population in millions of people of a country t years from 2005. What does f of 10 equal 8 represent? Okay, Well, 10 is my t value, right? So that's 10 years from 2015. So for part A, I would say in 2015, there are 8 million people, or there were 8 million people. Okay. And then what would F inverse of 12 equal 18? Well, remember, F inverse means I'm giving you a y value. So that is a y value, okay? The 18 is my x value, so that would be 18 years from 2005. So what's 18 plus 2005? So that means in 2023, there were, or will be, however you want to say it, 12 million people. So again, in a word problem, look at what you've got. Okay, if I give you an inverse sign, then I'm giving you a y value in the parentheses. If I'm giving you a regular function, it's the x value. Okay. All right. So, last but not least today, let's go ahead and evaluate each of these using the tables. Okay. F of g of 2. Well, that should be pretty straightforward. We've done this when we composed it. First, we find g of 2, and that's in the right-hand side. So g of 2 is equal to 0. And then f of 0, that goes on the left-hand side, right? Okay. So f of g of 2 would be equal to what? 3, right? So number 7 should be 3. Okay, number 8. G inverse of 4. Okay, so that means on the G table, I have 4 as my y value. What is the x value that goes with my y value of 4? Well, that should be 3 also. Okay. Now, number 9, we're starting to get a little bit trickier. I've got f of g inverse of 2. Okay, so g inverse of 2 means that I have a y value of 2. So I look at my y values of 2, and that gives me an x value of 0. Now I want the f of 0. Okay. Actually, sorry, that's f inverse of 0. So f inverse of 0 would be what? F inverse of 0 is just simply 1. I know you can't see the negative, but if there's a 1 up there, you just assume it's an inverse. If there's nothing up there, then assume it's regular. Okay, so number 10, we have g inverse of f inverse of 4. Okay, so f inverse of 4, that means I have a y value of 4 on the f table. So the y value of 4 gives me an x value of 2. Okay, so now I need, now that becomes a y value in the g table. So the g table has a y value of 2, which gives me an x value of 0. Okay. Number 11. Number 11, f inverse of negative 1. All right, well, I have a y value of negative 1. The y value of negative 1 gives me an x value of 3. So that 3 now becomes my new y value. So my y in the f chart again, so when I have a 3 as a y value, what's my x value? 0. Number 12, g of g inverse of 2. Now this, guys, you shouldn't even have to think about this one, Because if I take the inverse of something and then I undo that inverse by doing the original function, I should end up with what I started with. But let's just prove it. G inverse of 2 is 0. Now I want G of 0. Well, what's G of 0? It's 2. Okay, so whenever you see the repetition of that, where it's one of them is the regular function and the other one's the inverse, you should always end up with what? X. What's X in this case? 2. Okay? 13. G inverse of f of 0. Well, what's f of 0? F of 0 is 3. That now becomes a y value in the g function, and that gives me an x value of -1. All right, and last but not least, G inverse of f inverse of g of 3. Well, this sounds crazy, but again, just take your time. I want g of 3. The x so that 3 is an x value, so g of 3 is 4. Now I want f inverse of 4, so now 4 is a y value, and that gives me an output or an input of 2. Okay, so now that becomes g inverse of 2. That becomes a y value again. So when g is 2, y value is 2, the x value is 0. Okay, so now I want the inverse of 0. Well, I go to g of 0, and I find the x value there, and I'm finally done. I end up with 2. Alright guys, that's inverses. Keep in mind that I'll be posting another video for you, and some work for you for a review packet for you for over the weekend. So now we'll be posting that sometime later tonight or tomorrow morning. Have a great day, and remember, Tuesday, come to me with questions. All right, guys.